Okay, we are going to talk about our new note packet here, 3.1 functions. And all we are doing today is just identifying functions and talking about domain and range. Now, this whole first page that you see here is about vocab. So every bolded word, relation, map, graph, table, all important words that you need to know. So if you want to highlight or underline them, that is up to you. But again, these are the ones I'm talking about. So relation is our first one. And this is a set of ordered pairs. And here's an example. When I say ordered pair, we're talking about points on a graph. So something like 2, 4, -2, 7, and 0, 1. Now remember, to be an ordered pair, you have to have parentheses and you have to have two numbers with a comma. So a relation is a set of ordered pairs, which means more than one in a set. Sometimes on your homework you might see these fancy little brackets listed. That just means the word set. All it is a fancy bracket. So that is a relation. Second word is a map. Now this is a math map, not a history map. How each x value is related with each y value. How each x is related with y. So here's our picture of our map. So I'm going to list all of my x's from up here. I'm going to go least to greatest. So -2, 0, and 2. Normally when we list x's, we like to go least to greatest. Now when I list my y values, it doesn't really matter if they're least to greatest. We can if we want. So if we did it that way, it would be 1, 4, and 7. Now the cool thing about a map is that they do not have to coordinate across from each other. What we're going to do is actually draw arrows. So if I look here, 2 coordinates to 4. So I'm going to draw an arrow from 2 to 4. This tells me the ordered pair is 2, 4, not 2, 7. My next one here says -2, 7, so here's -2. Draw my arrow down to 7. So -2, 7. And then the last one was 0, 1, so I'm going to draw my arrow up here to 1. Now I know it looks a little messy, but do the best you can. Follow your line right to your arrow. This is called a map, something with arrows. So relation is a set of ordered pairs. A map is how they're related. Now we have a graph. So let me highlight this word. Now this is something you've seen before. All we're doing is plotting each point, and remember this is called a coordinate plane. The XY is called a coordinate plane. So do your best. I know it's hard to read. We're going to plot these points on the coordinate plane. So I'm going to go 2, 4. So right 2, up 4. Here's that first point. Then I'm going to graph -2, 7. So I'm going to go left 2, up 7, which is all the way to the top of this plane here. And then 0, 1, so I don't go left or right, I just go up 1. So this is the point 2, 4, this was 0, 1, and this was -2, 7. So these are 3 different ways that this group of ordered pairs, this relation, can be shown. The fourth way, and probably the way you're going to see the most, is a table. And this is just a straight up, we call it an XY table. So that's what I'm going to write here. XY table, because one column has the X's, one column has the Y's. Now this is important that X and Y must be across from each other. This is a little different from a map. So I'll let you get that down. A map, it doesn't matter where they're located because we have arrows. In a table, they do have to go directly across from each other. And because we like to do least to greatest from the x's, I'm going to start with my x of negative 2, and that y value was 7. So I'm using this point right here. And then I would go to 0 and 1, and then I would go to 2 and 4. Now right here, we want the x's, least to greatest. The y's do not matter. They just have to be directly across from each other. So these are the 4 ways you're going to identify functions today. A relation, which is a set of ordered pairs. A map, how are they related to each other? That has arrows. A graph, we know what graphs look like. These are just points. And you might see an XY table. These are ordered pairs directly across from each other. Now if you want to, these are kind of 2 separate parts. So I'm going to draw a little squiggly line here, because these are how functions look. Now these are the important pieces about functions. So we have domain and range, function, independent and dependent variables. I'm sure you've seen some of these words before. Domain and range are going to be very important for the rest of the year and for the rest of your math career. Domain is the set of all inputs. So that's just a fancy word for saying all of the x's. So if I want an example and I want all of the x's from above, here are my x values. So the domain, negative 2, 0, and 2. I'm just listing the x's. So if domain and range go together, domain is the inputs of x, range must be the outputs of the y values. So domain is x, range is y. And then same thing, I'm just going to list the y values. So the range here is 7, 1, and 4. Domain, x's, range, y's. Now, second most important word of the whole day is function, because that is literally what this section of notes is called, functions. This is where a domain is paired with only one y value. So this example up here in our table, negative 2, 7, 0, 1, 2, 4, this is a function because no x's repeat. Negative 2 goes to 7, 0 goes to 1, 2 goes to 4. Every x has only one y. So this is a function. And then lastly, independent and dependent variables. You've probably seen these in science class a lot. The independent variable is the x's. That means it stands alone. The y values are the dependent because y changes depending on what x is. So if I plug in 4, I could get a different answer. If I plug in negative 2 for x, I could get an even different answer than before. So my answer depends on what I plug into the function. So once you have all this down, go ahead and flip the page. I'll do that myself. Now all we're doing is practicing, okay, is this picture a function? Is it not a function? Here are the 2 ways. If we have ordered pairs, a map, or a table, here's the question. Do the x's repeat? If x happens to be 2 and then 2 again, it is not a function. If the x's repeat, not a function. If they do not repeat, it is called a function. Every x has one y. So that's for ordered pair, map, or table. If we have a graph, we do something called the vertical line test. So I'll go through that when we get to number 3. I don't want to confuse you too early. First thing we're going to talk about is right here, ordered pairs, map, or table. Do the x's repeat? So when I go to number 1, first of all, this is a picture of a map. because it's got the arrows. When I have maps, I just list the domain, which are the x values. So I say, okay, the domain, I have to do a fancy bracket, 1, 0, and 3. It doesn't have to be in order. If you do 0, 1, 3, that's fine too. And range are the y values, so all of these ones. So I'm going to do my fancy bracket, 1, 2, -2. So I listed my domain of x's, I listed my range of y's. Now determine, is this a function? If only one arrow is coming out of every x, that means the x's do not repeat. So if they do not repeat, this is a function. This is a function. So we've got a map, domain, range, this is a function. Number 2 is a picture of a table. So I'm going to mark that over here, XY table. So again, we're following this guideline here. Do the x's repeat? Okay, domain are the x values. So fancy bracket, list my x's, 1, 2, 3. Range is the y values. Fancy bracket, 2, 4, 6. Okay, is it a function? X's are 1, 2, 3. They do not repeat, so this is a function. So if you want to write a little note here, x does not repeat. This is true for both of these questions. X does not repeat. So map and table. Now I'm going to skip number 3 for right now. Let's do 4 because we know what this picture looks like. This is a map because it's got the arrows. So if my domain are the x values right here, I'm going to list them. -1, 0, 1, and 2. Oh, my bracket got a little crazy. Range, I'm going to list the y values. Excuse me. 4, 5, 6, 7. Now here's where maps can get tricky. Right here, we can see that -1 goes to 4 and 5, which means we have an ordered pair -1, 4 and -1, 5. So this is not a function because the x value of -1 repeats. Not a function. If there are 2 arrows coming out, if x is listed twice, not a function. There are too many x's related to a y value. Okay, so we practice maps and we practice tables. This is a picture of a graph. Yes, I know it's a circle, but it is on a coordinate plane. Now if we go back up to the top and look how it says vertical line test. So put your pencil top to bottom, so I have the tip of my marker facing towards the top of my paper. This is a vertical line. If I put it on my graph, look here and here, my graph, my circle, touches my line right here and right here. If it touches more than once, if it touches 2 times, not a function. Okay? Not a function. And we would say this fails the vertical line test because it touched my line 2 times. My pencil was vertical, touches here and here, that is a fail. Now, the other thing that's different about a graph is that domain and range are written differently. We use this thing called interval notation. So when I talk about domain on a graph, we're always going to go left to right. So I'm going to draw these little arrows here. So just like we read a paper, we're going to start on the left. I'm only looking at the x values right here. If I start on the left, my x value is at 0. So I'm going to put a 0 here. Then I'm going to do a comma. And if I go all the way over to the right and I trace this down, I'm going to guess this goes to about 11. So from left to right, my graph goes from 0 to 11. And because my graph touches 0 and 11, we're going to do these things called brackets, because that means it's equal to. So this is a really, really, really fancy way of saying that a compound inequality, so our x's are between 0 and 11, they're equal to. So we do brackets. That's what a bracket means. So instead of doing inequalities, we're just going to do a simple, it goes from 0 to 11, and they're equal. So range is very similar, but it's the y value, so we're going to go up and down, but always start at the bottom. So now this time I'm looking at the y-axis here. So if I start at the bottom, it's at -2, comma. It goes all the way up to the top, and if I draw a line, it looks like it would go to about 9. And it does touch, it's a closed line, so this would be equal to with a bracket. So again, this is like saying -2 less than or equal to x less than or equal to 9. This is just a much simpler way to write it. And this is going to take a lot of practice, and that's okay. So from left to right, it was 0 to 11. Up and down, it was -2 to 9. That's our vertical line test. Okay, we just have one more page, so I'm going to go ahead and flip. I do have this linked on Schoology if you miss anything. Now, very similar to what we talked about on the other page, this time we have 2 sets of ordered pairs, and then we have 2 graphs. So we're going to do the x's repeat? Does the line pass the vertical line test? So here, is this a function? Okay, so my x's are 1, 2, 3, and 2. Now remember, that question is, does x repeat? So here, does x repeat? Yeah, 2 happens twice. So not a function, because x repeats. So now, domain, I gotta list the x's. Because these are ordered pairs, I'm just gonna list 1, 2, and 3. And yes, 2 repeats, but I don't need to write it twice. And then range y values, same thing, fancy bracket. I'm going to list the y's, 2, 3, 4, and 1. With a fancy bracket. The x's were 1, 2, 3. The y's were 2, 3, 4, 1. Not a function. And if you haven't already started number 6, same exact thing. Do the x's repeat. So I'm going to go back to my domain, 5, 7, 9, 11. Those do not repeat, so this is a function. So fancy bracket, my domain, 5, 7, 9, 11. My range are the y values, 2, 3, 4, and 4. So if the y's repeat, that is okay. Y is allowed to repeat. Ooh, that's a W. Sorry, that got kind of jumbled up. Y is allowed to repeat. So when I write the range 2, 3, 4, I don't have to write 4 twice. The only thing I care about in functions is does the x repeat? So x's go for ordered pairs, maps, and tables. These 2 are graphs, so we're going to do that vertical line test. So here's my vertical line up and down. if I go here, my vertical line test covers up the entire graph, which means every part of this line is touching my test line. So this cannot be a function. It fails the test. Okay? And domain, because domain talks about the x values this way, it only is right here at x equals 2. There's nothing to list. We literally just write x equals 2 because that is what this line is. When I do the range, I have arrows that go up and down forever. So in the math world, we call that infinity. And we have two options. Option 1, we can say all real numbers. And the symbol for that is 2 lines with a capital R. This just means that no matter what I plug in, so if I plug in x equals 2, I'm going to get every single number that exists for y, because this line is going to go up and down forever. The second way, in set notation, we use parentheses, negative infinity, because it's down here forever, comma, positive infinity, because it goes up here forever. And we use parentheses because infinity goes on forever, we can never equal it. So these are your two options for a range. And this won't happen too often, but it does come up when we have graphs. Okay, one more graph. Number 8, is this one a function? I'm going to put my vertical line test. Now, if I move my vertical line, if I move it, I move it, I move it, no matter where it is, it's only touching one time. So I'll do it one more time. No matter where I move it, my pencil only touches my vertical line one time. So this one is a function because it passes that test. So if I go to the domain, remember domain is left and right. So if I start all the way over here, it's going to keep going at this angle forever and ever and ever and ever. This is going to be all real numbers. Oh, excuse me, I'm so sorry. Or this is one where we go negative infinity to infinity. It goes from left to right forever because of these arrows. It goes this way and this way. Now range, the y values, remember that's up and down. And we always start at the bottom of our graph. So because I have arrows pointing down, it's going to go on forever. So negative infinity with a parenthesis. Now if I go up, 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 up till my graph stops, right here, this is at 2. So my graph goes from down here forever all the way up to 2, and this one gets a bracket because my line is touching 2. So that is it for functions. If you have ordered pairs, a table, or a map, do the X's repeat, yes or no. If you have a graph, then that's when you're doing that vertical line test on your paper. Does it touch more than one time, yes or no? Domain are X's, range are the Y values. Now, very last problem, practicing independent and dependent variables. This is going to pop up in your homework. Here we have an equation. It has the number of avocados you have left after making guacamole. Identify independent and dependent. Okay, independent is the B value, guacamole. Dependent is A. Okay? So if I were you, I would make an XY table. Or I would make an avocado table. Sorry, a guacamole table here. So B value, A value. So here it's guac, and here it's avocado. And the reason for this is because it's the number of avocados left after making guac. So it's not the other way around. I made a whole bunch of guacamole, then I'm seeing how many avocados are left. It doesn't matter what I started with. I'm going to make 8 batches of guacamole. How many avocados do I have left? So my B values here is the domain. 0, 1, 2, and 3. So if I fill that in, and these are batches, right? No batches of guac. 1 batch, 2 batch, 3 batch. I'm trying to figure out how many avocados are left every time I make another batch of guacamole. So using my equation, I'm looking for A. So I've got -4. Okay, now B, I have B. That's 0 plus 14. So if you don't have a calculator handy, this ends up being 14 avocados left, because -4 times 0 is 0 plus 14. Okay, same thing. Now what if I make 1 batch of guacamole? How many avocados are left? So avocados equals -4 times 1 batch plus 14. So -4 times 1, that's -4 plus 14. I've got 10 avocados left. Okay, we might start to see a trend. So what happens if I make 2 batches of guacamole? -4 times 2 batches plus 14. -4 times 2 is -8 plus 14. I've got 6 avocados left. And if I make 3 batches, I'm sure you've already seen a pattern, but I'm going to write it out anyway. -4 times 3 batches of guac plus 14. Well, -4 times 3 is -12 plus 14. There's only 2 avocados left. So every batch took up 4 avocados. So what is the range? We just found that. Our range of avocados is 14, 10, 6, and 2. We plugged in our domain to our equation, we got the range. Guacamole was independent, avocados depended on how much guac. Now again, I have this video linked in Schoology on the calendar, so if you need to watch it again, if you missed anything, go ahead and go back, or you can check out the answer key in Schoology. Otherwise, you can keep your notes out. You have a homework assignment to work on, and then I will see you next class. Thanks, guys.